Okay. So most angles are drawn from the positive x-axis. However, we saw when we did some of the problems earlier, when we talked about bearing or heading, you draw them from 90 degrees and go clockwise. However, even though you draw them from the 90 degrees clockwise, you still have to figure out what the angle is from the positive x-axis, because you are doing problems that are cosine comma sine. And when you do cosine comma sine, your object assumes that you're going from the positive x-axis. It doesn't know that you're doing a heading or a bearing problem. So I want to fly on a heading of 30 degrees, which means this angle in here is 30 degrees. However, that is not what goes in our equation. What goes in our equation is this angle from 0. And that one should be 60 degrees. That is what goes into our equation, not the 30 degrees. The 30 degrees gets us where the vector is, but mathematically, when we put it into our equation, we need to put in 60. If you put in 30, you're not going to get the correct magnitude for this. So again, I'm flying 300 miles per hour, so that is my magnitude. And so my vector is 300 cosine 60, comma 300 sine 60. And then if we plug 300 cosine 60 in the calculator, we're going to get 150. If I plug 300 sine 60 in the calculator, I'm going to get 259.8. So that's 150, 259.8. And if I double check it in my Pythagorean theorem, 150 squared plus 259.8 squared, that is going to give me my magnitude of 300 for that. Okay, next one. You fly a plane going 270 miles per hour on a bearing of 291 degrees. So if I draw my picture, 291 degrees, let me draw in an arrow. I want it blue. Okay. So for my arrow, 291 degrees, since I'm doing bearing, oops, hold on. I'm going to have to start up here, and I'm going to have to go 291 degrees. So this is 90, 180, 270, which means I have to go another 21 degrees. So that means this angle in here is 21 degrees, which means this angle here is 180 minus 21, which means that's going to be 159 degrees, is what goes into my equation. What goes in your equation is always from x, your positive x-axis, in the direction that your normal unit circle goes. So my vector is 270 for my magnitude, cosine 159 degrees, 270 sine 159 degrees. If I plug those in the calculator, I'm going to get negative 252.07, 96.76. So 252.07, 96.76. And then my magnitude, if I want to double check it, negative 252.07 squared plus 96.76 squared is going to give me my 270 miles per hour, if you want to double check it. Okay, so you can add two vectors together to get a resultant vector. So if let me find my arrows. So if I add this first vector here plus this one, this is my resultant. Okay, so a few things to keep in mind when you're dealing with planes. When you fly a plane, you also have to take into account the wind. It's affected by the wind, so it's either going to make it speed up or slow down. And it's the same thing for a boat or if you go swimming. Your plane or your airspeed or your boat or whatever speed plus your wind speed or your water speed equals what they call your ground or your actual speed. So when you add those two together, it's either going to make your plane speed up or slow down. You also need to know, kind of we did on the last one, define your magnitude of the resultant. You're just doing Pythagorean theorem. Also to get the direction of where your resultant vector is, you need to know your tangent is y over x. It's your change in y over your change in x. It gives you the reference angle. So depending on where it is and whether you're doing a heading or bearing problem, you also need to figure out your angle from 90 degrees clockwise for heading problems or from 0 counterclockwise for all your other problems. So if your original problem was a heading or bearing problem, you need to give me your answer as a heading or bearing from 90 degrees clockwise. If it was originally a direction, then give me a direction problem. Okay. A plane flying on a heading of 153 degrees at 650 miles per hour. The wind is blowing towards the southwest at 40 miles per hour. Find the actual ground speed, magnitude, and heading of the plane. So first we need to write the vectors. You've got the plane plus your wind equals what you're actually going. It's either going to make you speed up or slow down. So for my plane, I'm doing, this is my plane. I'm going 153 miles per hour. Oops. Actually, let's back up. Let's do the angle first. So I'm going to draw two different vectors, one for the plane and one for the wind. The plane is going on a heading of 153 miles per hour. So let's draw in a vector for that. Okay. Oops. Let's short. Oh, I didn't mean to do that. Let's shorten this one. Okay. So if this is 0, if I want to go 153 degrees of a heading, then I'm going to go clockwise 90, which means I need to go another 63 degrees. So my angle, oops, let me change colors. In here is 63 degrees. However, what mathematically goes into your equation is this angle, which is 360 minus 63 will give you 297 degrees. That's for my plane. And I'll write the equations in a second. For my wind, okay, let me draw, let's do a red one. Okay, it says that it's blowing southwest. Okay, so if it says southwest, here's, oops, here's south, here's west. So when I say southwest, I'm truly talking about halfway in between. So that means, oops, let's do red. Now let's make this green. So that means my angle in here is 45 degrees, which means my angle here is 225 degrees. So my plane vector is, I'm going 650 miles per hour at an angle of 297 degrees. I'm going 650 miles per hour sine 297 degrees. On the next screen, I'll turn them into decimals. For my wind is going 40 miles per hour. So I'm going 40 miles per hour and in the direction of 225, 40 miles per hour sine 225. Okay, so if I want to find my actual ground speed vector, I'm going to have to basically add the two together. So I'm going to have to do 650 cosine 297 plus 40 cosine 225. When you add these two things together and stick them in the calculator, you're going to get 266.8. And then when you add the 650 sine 297 plus your 40 sine of 223, you're going to get negative 607.44. So I'm going to have to do the next screen to get your actual ground speed and your heading.